Welcome to the Rich Report, a podcast with news and information on high performance computing. Today, my guest is from Adaptive Computing. We have the CEO of the company, Rob Clyde. Rob, welcome back to the show today.
Rich, it's a pleasure.
Well, Rob, I'm glad you could come on. I haven't seen you guys since, supercomputing in Denver, but I understand you have some very exciting news to share.
Yes, we're going to be talking about a solution from Adaptive Computing that we're calling Big Workflow. And I think it's going to be really exciting to our audience. As we hinted at during supercomputing, we're seeing this collision between HPC, cloud, and big data. And a couple of the interesting things about it is that we're seeing big data driving this collision as companies are collecting massive amounts of information, struggling, frankly, to do much with it. And for those of us in the HPC community, it's fairly obvious that many of the answers of how to do something with that will come from the HPC side of the equation, and that's why we're seeing this type of collision. So we're really excited to talk about Big Workflow and how we can use that to accelerate insights and be able to really drive that into the future. So for those who may not know, I just thought it'd be useful to give a little bit of background on adaptive computing. We come from a long history in the HPC community, but we've also done a lot in terms of scheduling and optimization software for cloud and for big data as well. So we're one of those companies that has a strong heritage, but has also found ways to work with commercial organizations, data centers, private clouds, etc. Our main technology is called Moab. Moab software. It's used in some of the largest compute centers in the world, such as at Oak Ridge National Labs. This technology is heavily protected by patents. We have 50 patents now issued or pending. So for a small company, a little unusual in the strength of the intellectual property that we have. And we've obviously used this for a number of years and continued to iterate on it. So it is battle tested and been around for over 10 years, which is important in these big environments. It's important to know we've had a chance to cut our teeth. Strong venture capital investors, lead investors, Intel Capital, also Tudor Growth Equity, Epic Ventures, and then finally our audience will recognize all the partners that we have here, such as HP, Intel, SGI, Cray, IBM, Microsoft. We have a broad customer base. We especially do well in areas like oil and gas and energy. The energy sector has really been good for us. Finance and insurance, and anywhere where you have those types of big data, the actuarial tables, you've got to crunch through that and play those what-if scenarios. Manufacturing and also government, been very strong on the government side. And then, of course, traditional research such as in academia or pharma, life sciences, even the atmospheric area with organizations like NOAA that we play in. As I mentioned, we've been around in the HPC space for some time, and what we really do there is be able to accelerate productivity, both in terms of maximizing utilization, where we can drive it up to as high as 99%, but just as importantly, the throughput side. Nobody wants an environment where all the systems are heavily used, but not much is actually coming out. They're just thrashing, and so we're very focused on making sure that the job throughput itself is maximized. We've also seen a ton of interest in energy consumption and lowering power. So typically we can lower the power requirements with some of the new green capabilities we have 20% lower. And in addition, we're making it easier for users to be able to submit and manage the jobs and get quicker time to the results. We've also automated the uptime. So the idea there, of course, is prevent job failures, respond to those failures, reduce the missed deadlines, and of course, lower the overall cost to support the environment. Very importantly, though, is to automate the SLA enforcement. This is really key, and those SLAs are often time-related, but they can be other types of things. And whatever those SLAs are, there are ways in which we can put that into Moab so that we can balance and ensure that the resources are fairly shared. And then also be able to deal with the budgets as well, with showback and chargeback. It's key to be able to pay for this stuff fairly based on actual usage. And then finally, it's all grid and cloud ready. This is a huge area. In fact, in a recent IDC survey, 25% of HPC sites actually self-identified as already doing cloud in this area. So that's huge as well. And then, of course, we play on the cloud side also, where we go well beyond basic cloud of service catalog and initial placement with the optimized cloud capabilities, where we can actually consolidate workloads, move them around, and migrate them so that they are getting better utilization. We can ensure that we can, again, do auto power management to reduce costs. We can look at self-healing and, very importantly, decommissioning. What we're really seeing, though, is that it's really not just about HPC or cloud for efficiency. What it's really about is HPC and cloud for a purpose, which is to accelerate insights. And this is where big data, I think, is really changing the world. So if you think about it, in many ways, big data changes the world for traditional data centers and private cloud. And this chart kind of shows why. In a traditional data center or IT cloud environment, those apps are typically things like email servers, web servers, CRM systems, etc., and the organization is looking for equilibrium or uptime. These things run in a steady state. They run forever. You oftentimes have many apps per server, each in their own VM, and you have a relatively light compute load and a relatively light data load compared to a big data situation. Scheduling, while there may be some, it's certainly not much of a need in this kind of environment. It's really more about where you're going to place workloads. When you get to big data, it starts to smell a lot more like HPC. And in fact, as we'll mention, IDC, in their most recent survey of HPC sites, had 67% of those sites self-identify as already doing big data. And so in many ways, we've been doing this for a long time in our space, and we can make this happen in the data center. But if you think about these big data workloads, they're different. It's not just about steady state. They have changing needs and load. Typically, you'll have deadlines when you have to get certain types of analyses done, certain simulations done. Those things collide. How do I get it all to happen? These types of workloads are going to run until you get the insights. You'll tweak them, you'll run them again. They're, in our parlance, batch jobs. Many servers will typically be needed per workload. Very different than a traditional IT app. Well, virtualization can definitely play a role and can provide abstraction and make it easier. It can't be the answer to this situation because you have to be the cluster. It's not only is it data intensive, but it's also often compute intensive because simulations are really key. I want to build up a model so that I can predict the future or that I can discover something. And in order to do that, there is often an awful lot of crunching that's going to go along with it. And so, of course, scheduling goes from not needed very much to suddenly becoming crucial. So you might have things like Monte Carlo simulations or recommender systems or weather prediction or what will happen if I change this particular price. And if you look at that, we really get this collision as shown in this picture of cloud, HPC, and big data. And we can use that to accelerate insights to gain a competitive advantage. And so it's more than just the analysis, but actually providing the necessary infrastructure so that data scientists can quickly do that type of analysis and not have to worry about how do I actually get this thing to run given the type of resources on the compute side and the data side that it's going to suck up. So if you listen to Gartner, they definitely are hearing all about the opportunity from big data. Business leaders most often associate the term opportunity with big data. It's interesting. It's not cloud, it's not technical computing, it's big data. But if you think about it, it's all three of those that actually will let you get the answers out. In addition, big data is key to enhancing the business performance in many industries. And in fact, from a recent survey of board of directors, 50% of the respondents also saw IT as the way to change the rules of competition in the industry. But IT is having a challenge, as we saw in the earlier slide. They've got to have a way to unlock that big data. So let's look at that challenge. If you think about it, the data center is the logjam. And that's because these data analysis and simulations are often done on a manual basis. They're time-consuming, multi-step. In some ways, this is a little foreign to us in the pure HPC environment because, we figured some of this stuff out. But you get to the data center and this isn't their type of application that they're used to. And there are complex dependencies. These workflows are going to use multiple applications. And you've often got these things in silos, and the data is stubborn. If it's in a particular silo, you can't move it easily because of how big it is. It's big data. Everybody knows you can't move large amounts of data quickly from one location to another unless you're going to move it physically. That's a very manual process. You're certainly not going to move it over the wire or put it up in the cloud unless you're talking a few gigabytes. It's just too hard and takes too long. And certainly our audiences say that's not going to get me very far. I've got terabytes, petabytes of information that need to be dealt with, and that means we have to find ways that we can work across those silos. So as I said before, IT typically says we know how to collect and store the data, but we're really struggling to provide that infrastructure so that we can extract the results to impact the business. So this is where we can eliminate the logjam. And the idea here is to streamline the workflow. The key, leverage scheduling and optimization and the advanced policies so that you can meet those SLAs. And you can do it across the entire data center environment. How do we get that done? Again, it's tying together HPC, cloud, and big data. We're using a term we've coined, which we're happy for everybody to start using because I think it really talks about the problem at hand, which is big workflow. Maybe a simple definition for big workflow is big data plus workflow. And that workflow definitely has elements of it that need to come from what we've learned over many years of working with massive amounts of data in the HPC community. So with Moab, we can eliminate that logjam with big workflow. So let me talk about some ways we can do that. So big workflow accelerates the insights that can inspire those game-changing, data-driven decisions. 3 key aspects to big workflow. Number 1, it needs to be able to unify the data center resources. So you have to be able to run across various aspects of that ecosystem. That means public and private cloud, HPC, both virtual machines and bare metal. We have to have ways that we can reach across silos, and that's going to be key as we move forward into the future. Then we have to be able to optimize that analysis process. That means we have to be able to increase throughput and productivity. Scheduling will be key in that aspect. And reduce the cost and complexity and the errors. Automate as much as possible. And then finally, guarantee that service to the business. This is key. You want to be able to ensure SLAs. So that means you have to do the preemptions, the reservations, the aspects that ensure that SLAs are actually met and that you can look out into time and also have an idea of space or the resources that are available as you flow across that time. Of course, you want to maximize uptime and utilization through this whole process, and you want to be able to prove that you actually did deliver those services. And then finally, you want to be able to pay for and ensure that the resources are allocated fairly. And so this is, again, where accounting and that kind of aspect will come in. So let me give you an example. This is a case study around Digital Globe, and it's what I like to call really big data. I like to look at some of the edge cases because if you look at big data, really big data, and can plan for that and have software that can deal with that and an infrastructure that can deal with that, you'll have far more confidence that you can handle situations with maybe smaller big data. So Digital Globe is a global satellite imagery provider, and they will provide services to customers all around the world, both commercial and government customers, and provide analysis of satellite imagery, and they will tell you it's the analysis that's the value, that's the real product, not just the image they provide, but really what does it mean. And they will do this for a fee, and they've got lots of customers and this huge workflow stream. In the midst of all that, a challenge, and we'll talk about this as we go on. But the challenge is they also happen to have contracts with first responders around the globe where they have a 90-minute SLA. They have to actually provide information, analysis to the folks on the ground in the advent of emergency. Think Hurricane Sandy, think the tornadoes in Oklahoma, or the recent typhoon in the Philippines. They have to respond within 90 minutes with information to those folks on the ground. What a challenge. Because if you were to do this perhaps in the most obvious fashion, you would provide dedicated resources for each of those customers, and then when emergencies occurred, you would spin that up and make that go. That obviously gets extremely expensive and is going to be difficult to actually pay for, and was not the way they wanted to do that. But just to then further talk about the challenge, when you're talking about satellite imagery and covering the globe, that's about 2.3 billion square kilometers. However, there's many different sensors. Think infrared, think other aspects. So it's even not just one globe's worth, it's many globes worth. And the end result of that is 2 petabytes of raw imagery that's collected every single year by Digital Globe. From that, in the initial passes and analysis they do, they create 8 petabytes of new product every single year that has to be stored and analyzed. And yes, the historical information has to be kept because it's comparisons to prior periods that are often part of the analysis that they will do. So as I mentioned before, got this big data. That's great. They're doing all this analysis, things like looking at parking lot densities, for example, for Walmart is one that they've done before. And in the midst of all that, at any given time, and it probably happens fairly often for these guys, a disaster can occur, and they have to respond within 90 minutes. And this picture shows Typhoon Haiyan after the event occurred. And if you hit the click forward, you'll actually see that occur, where you go from the normal state to after Typhoon Haiyan made landfall. And in the first few days, 19,000 square kilometers of imagery in those hardest hit areas was collected and shared with the first responders. I mean, this is key because you've got to be able to know, hey, where are the hardest hit areas? Where can I actually get rescuers in? I mean, how do I get in? Any given road may be wiped out. How do I get out? Where did the buildings go? Because if you look at the disaster picture, a lot of buildings are gone now. Where are they? Where might people be found? All of this needs to be there. So Digital Globe uses MOAB. MOAB is at the data center core, and they use that to help break down the silos and increase that maximum workflow capacity and optimize the analysis process, as well as to help in being able to do the necessary prioritization and preemption so that Digital Globe can respond within the 90-minute SLA. And as they have said, without MOAB, Digital Globe could not do what we do responsively. Let me just kind of wrap up with a recap of this study that IDC recently did. And as I mentioned, the real key as we move forward is to recognize that it's not going to be just big data and cloud, but that HPC is really crucial. So a large proportion of the sites are applying big data and methods to their problems, and there's a steady rate of growth in cloud computing for HPC. We at Adaptive Computing aren't surprised either, and a survey that we did at Supercomputing and also at a couple of other recent events, 91% of the respondents said that they felt that the future would be built off of technologies for big data, cloud, or HPC combined in some fashion. 91% saw this combination likely to occur. So if you look at IDC's growth projections for big data, we're looking at going from $10.9 billion in 2013 to $23.8 billion in 2016 in terms of big data revenues that will be coming to the market. But as I indicated earlier, 2/3 of HPC sites said they're already doing big data analysis. I would guess the number is actually even higher than that. These are the ones who self-identified. It's some that weren't quite sure exactly whether or not what they did was big data. Interesting enough, 30% of the available computing cycles are devoted on average, to big data analysis work. So this is already huge within the HPC community. And then with the cloud computing report, as I indicated before, from just 2011 to 2013, the HPC workload rose from 13.8% to 23.5%, almost a doubling in 2 years. And I would predict we're going to see continued growth there on a very rapid basis as we move forward. And then as they also said, as there is no shortage of big data to analyze and no sign of it slowing down, combined uses of cloud and HPC will occur with greater frequency, creating market opportunities for solutions such as adaptive big workflow. So that's really, really key. And then the last thing I'll say, it's a huge opportunity as well for our listeners, for those in the data scientist realm, in the admin realm, as HPC becomes ever more relevant, as both IDC and adaptive computing are actually projecting here. We believe that many of the ways that big data will be dealt with will come from techniques and methodologies that were really built in the HPC space. And with that, Rich, I'll hand it back to you for any final questions.
Thanks for that, Rob. This is a fascinating concept, the idea of big workflow. And I wanted to ask you about barriers to entry, right? Because you talked about this satellite case study is interesting. But what is their HPC resource? Did they go out and buy a supercomputer, or did they have a small cluster? I mean, that would seem to me to be a key piece of this, or is the cloud what enables that?
Yeah, so all are pieces, but they did have a data center, but it wasn't very HPC-like. They actually went out and hired someone who had a strong HPC background. Back to my point of mobility for those who have this kind of background, because when you're talking about that kind of data and that type of computational need, they were very bright and said, "Hey, let's go bring somebody in who's an expert from that perspective, and let's transform our data center to be more of a bit more HPC-like and be able to handle these types of workflows for big workflow." So in many, and we're different now. HPC is heavily around x86. As you talk to people who run large data centers and try to deal with big data, they will tell you in a heartbeat that what's missing is the software in terms of managing that kind of environment.
Sure. And along those lines, Rob, you mentioned the maturity of Moab as a technology. And I was wondering if you could describe, your advantages of coming at big workflow from the HPC side with that versus, let's say, somebody from cloud side coming at this and trying to figure out HPC from their aspect. That would take years.
Yeah, it would, and it does. We've played in the cloud space, and any of our technical guys will tell you cloud is way easier than HPC. Just because of the scale, and this is why it becomes so important on the big data side. The scale starts to tip the balance towards someone with a heavy HPC background probably having a leg up. The cloud is fairly straightforward. There's a lot of things that are heavily, for example, similar to grid in HPC. But I'll give you an example. I was on a panel with a number of my fellow CEOs that came from cloud companies. Of course, we do cloud at Adaptive as well, and we were talking about big data. This was about a year ago. And I remember they were all talking about how they were spreading the data all across the cloud. There was a little bit stored here and a little bit stored there in various data centers, and now customers could access that big data and do all this analysis. And they were talking about, gigabytes of information that they were managing to do this way. And I remember it, it got to me, and I stopped and I just said, I guess I'm just really different, because I'm thinking when we're talking about big data, let's talk about big data, petabytes of information. And I went through some of these customer stories, and you just saw people's mouths and jaws dropping in the audience. I said, I'm here to tell you, we're not going to be able to analyze that and deal with that size of data by breaking it up into little pieces and storing it in the cloud all over the world. It just isn't going to work that way. The speed of light is against you. You can't actually get stuff to run quickly in that kind of scenario. As anybody who has done this will tell you, you need the computation close to the data, and the data is stubborn and it doesn't move. You could do maybe some of the smaller big data that way, as we've talked about, but the really big stuff needs to be done in this other fashion. I'm not even talking about petabytes. I mean, if you've ever tried to transfer a single terabyte to the cloud, that's, unless you're going to actually ship the drives, which is one option, you're talking weeks to months to move that up to the cloud. It just isn't going to work. And so when you start talking about how do organizations actually get the insights they want, let's stop being bigots around exactly what kind of infrastructure is needed. They are already recognizing more of an HPC-like technique that's needed in order to do that. And so that puts us at a tremendous advantage over a traditional cloud-only company which doesn't think about the really big data. Scheduling is a complete afterthought, so can't handle the types of workloads that we're already talking about. And on the other hand, for somebody that only did HPC and has never moved outside of that arena, they don't have enough insight into the way that data center does things. Some of the budgeting aspects, for example, you got to understand how they do business. The terminologies are important, and sometimes in the HPC community, we get so hung up on our own terminology, we might lose the data center guys. And it's important that we can, if we're going to be be able to advance our careers, and it's important to be able to talk both languages, and that's something we can do here at Adaptive Computing.
Well, Rob, I wonder if you could speak a little bit to the opportunity for the rest of the HPC community that might come out of big workflow, because that's my primary audience. And as we saw at supercomputing at SC13, everyone was talking about big data. Whether it was a university or a vendor, it was everywhere, right? But what is big workflow? How is that gonna help them float their boats?
Yeah, I just couldn't be more excited about the career opportunity for folks that have an HPC background. First of all, let's talk about our users in the HPC community. Many of them are these data scientist types that we've been talking about. I think they are in the catbird seat because commercial industry can't hire these guys fast enough. These have to be people with some programming skills, with strong data analysis skills, with pretty good math skills. So, imagine, you got to get people that can write the Monte Carlo simulation or other types of simulations and actually get this done. And we've definitely got those kind of people in our HPC community, probably folks listening to this podcast or either people we know that are in that. They are in a fantastic position because those data scientists, I predict, many of them will be hired by commercial industry from that type of background on the HPC side, and certainly in academia, we would be so well behooved to make sure our students are well trained and understand those areas because I see this as a very strong career path. Secondly, for the admins of HPC environments, for those admins, particularly those who can get some data center experience in cloud, private cloud and public cloud experience to go along with their HPC experience, wow, really golden as we look at this environment. And the fact that many HPC environments are doing some cloud, and as I said before, Grid has some cloud-like aspects to it as well. I think that puts it in very good stead to have the option from a career standpoint but moving there and frankly having at least aspects of that traditional data center become far more HPC-like in order to handle big data. I think there are definitely opportunities there, and over the next few years, I think there's going to be a hunger for HPC and technical computing experts to be brought into perhaps less traditional, less research-oriented roles as a way in which they can help larger organizations handle big data. That being said, I think we're still going to have fantastic careers for those who want to stay on the research side because it's all about big data as well. So no matter how you look at it, I just see an expansion of career opportunities for those in the HPC community that keep their heads up and are willing to look out there and see what big data might mean to them and their careers as they move forward.
Well, terrific, Rob. Well, kind of a wrap-up question here. I mean, about big workflow. This is day one of the term. You want to get it out there. What's the next step for Adaptive, and how would somebody engage out there in the cloud with adaptive computing?
Well, first of all, we're on the web. Check out our website. Send us an email. It's fairly straightforward forward to do. We'd love to hear from you. Love to hear our thoughts. We have some blogs about big workflow that are out there. We'd love to have you post against those blogs and hear your responses and thoughts around big workflow. Our new website will be coming up as we speak. And so you'll see that on there. Please engage with us. Let's have a dialogue. We certainly are not going to claim to know everything about big workflow and what needs to be done. This is going to be a community effort for how we can make HPC far more relevant on the big data side. But we also have a white paper as well. We also have a white paper I encourage you to download as well that's out there that was written by an analyst that we'd love to have you take a look at.
Okay, we'll put a link to that here with the podcast. So, Rob Clyde, I want to thank you once again for coming on the show today.
Rich, it's always a pleasure. Thank you for having me on.
You bet. We'll see you soon. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.